research workshop number 3, topic of data analysis, where my colleague Dr. Tim Hilkin will walk you through the chi-square test of independence in SPSS.
As you likely recall, you will be conducting a chi-square test of independence when you have a dependent variable that is measured on a non-metric scale, so nominal or ordinal, and an independent variable with at least 2 independent groups. For instance, if we take the example from the Marketing Management Week 2 survey data that I introduced in the previous web lecture, we could test with a chi-square test of independence whether there's a relationship between the MRP team a student is in, measured on a nominal A, B, or C measure, and the intention to do interviews for the MRP, also measured on a simple yes or no nominal scale. The chi-square test then allows us to compare the proportions amongst or between these 2 nominal variables, as you can see shown below. And specifically, the test calculates a statistic that tells you whether the observed frequency or the observed distribution here between teams A, B, and C and their likelihood or their plan of conducting interviews differs from what we would expect if there was no relationship. If there was no relationship, then we would expect a completely equal distribution as shown here, and the observed distribution is compared against that. So in this case, we can clearly see that team A seems most likely, most willing to conduct interviews, and so the chi-square test statistic that we receive will likely support that the observed distribution is different from the expected, meaning there seems to be a relationship. We could here then draw the conclusion, in this case, that team A seems to be most willing to conduct interviews. The prerequisites for this test are that each cell, as you can see above, should have more than 5 respondents. So in the example here with only 1 respondent in the cells, we would need to acknowledge this as a limitation, or if possible, recombine groups into larger groups such that we have 5 respondents in each cell. The other prerequisite, of course, is that we are talking about 2 nominal or ordinal variables. If we now go to SPSS and actually conduct this test, we can do so by going to Analyze, Descriptive Statistics, and then selecting Crosstabs. And here we would enter the team a student is in, the IV into the columns, and we would enter their intention to conduct interviews into the rows as the DV. Then it's important that you go to Statistics and specifically request the chi-square statistic, and then that you go to Cells and include not just the observed, but as I previously showed, also the expected. This is the if there were no relationship distribution, so that we can compare these 2. In this case, it also helps to include the percentages rather than just the counts. So in this case, to compare within the yes and no, do you want to do interviews, the rows, I'm going to include these percentages. Then hit continue and run the test. And you can see, as the name suggests, you receive a crosstabs here, where team A, B, and C are plotted against the intention to conduct interviews, yes and no. We can see the observed count. So in team A, or 57 students who were in team A indicated that their team is planning on conducting interviews, 42 team B, 53 team C. Below that we can see the expected count. If there were no relationship based on the number of responses we have here, what would be the distribution or the proportions that we would expect if there was no relationship. And then we also have this expressed as a percentage within the role, and we have the same data for those who indicated that they do not intend to conduct interviews. At first sight, we can already see that if we compare the expected counts against the observed, there are some slight deviations in this case. So team A seems to be slightly more likely to conduct the interviews than expected. Vice versa here, the 44 observed is lower than the expected 48. Team B seems to be slightly less likely, and Team C very slightly more likely, we could say. Now the question is, but do these differences between the observed and the expected, are these differences statistically significant? And for that, we look at the chi-square, the Pearson chi-square statistic, which has a value of 3.264 here, and a corresponding p-value of 0.196. All the rules for determining the significance of a test, you'll remember that we will reject a null hypothesis, in this case the null hypothesis being the intention to conduct interviews does not differ across the teams. We would reject that if the p-value were lower than 0.05. In this case, the p-value clearly is larger than that threshold, and that means we do not have enough support to reject the null. Put differently, we do not have support that the intention to conduct personal interviews differs across the teams. So even though we're seeing slight deviations in the observed versus the expected count, the test shows us that these differences are not statistically significant, and hence we cannot draw a conclusion that the intention to conduct interviews differs across the teams.